right, we are going to go through the August 2019 exam, and we are going to start with the multiple choice. Okay. All right, so there are two sections of multiple choice. Here is the first section, Part A. Part A consists of 30 multiple choice questions. These are the easiest multiple choice questions. Yes, you may need to use the reference table, but you shouldn't really have to do any complicated calculations. So these ones are the easiest ones, so we're going to start here. Which statement describes the earliest model of the atom? So before I even look at the answers, let's think about the atom and how it changed over time. First, we just had a solid sphere with Dalton. And then Thomson discovered the electron, so he thought it was like this ball of positive with negatives inside of it. Then we had Rutherford, who discovered the nucleus. Thought the atom was mostly empty space, but we have electrons orbiting like that. Then we have Bohr with the nucleus, and then we have electrons in energy levels. And now we have the nucleus with an electron cloud. Okay, so which statement describes the earliest model of the atom? Right here, right? That's the earliest. Hard, indivisible sphere. Small dense nucleus, that was discovered with Rutherford. Negative particles in the atom, discovered with Thomson. And electrons in an atom have wave-like properties. That's the wave mechanical model, or the electron cloud model. In an atom of bismuth, okay, so here's what you need to remember. Atoms are neutral, right, which means they have a zero overall charge. The number of electrons, you have to remember that electrons are negative. So if the overall charge of the atom is zero or neutral, the number of electrons, which are negative, has to equal the number of positives. And which number of these particles is positive? Right here. Which symbol represents a particle that has a mass approximately equal to the mass of a neutron? Now, if you don't remember this one, this is an easy reference table question. So if I look at the reference table, table O is where I'm going to go. Okay, so looking at table O, equal to the mass of a neutron. So when I look at table O, the mass numbers are on the top, the charge is on the bottom. So approximately equal to the mass of a neutron. So here's a neutron, there's the mass of a neutron. What has a mass approximately equal? This one, a proton. There we go. An orbital is a region in an atom where there is a high probability of finding. So remember this model right here? That's where you find an electron. Which electron shell in an atom of calcium in the ground state has an electron with the greatest amount of energy? Well, let's go to the periodic table for a moment, and we will look up calcium. So here's calcium. It has 2 electrons in energy level number 1, 8 electrons in energy level number 2, 8 electrons in energy level number 3, and 2 electrons in energy level 4. That's not the question is asking me. It says, which ones have the greatest energy? Well, the electrons closest to the nucleus, so that's 1, have the least energy. And the electrons furthest from the nucleus, they have the most energy. So in this case, they are in energy level 4, because remember it was 2, 8, 8, 2. So these electrons have the least energy, and these electrons have the most energy. Energy level 1, energy level 2, energy level 3, energy level 4. As the elements in period 2 are considered in order from lithium to fluorine, there is an increase in. So let's look at the first 2 elements. First, say 3 in period 2. We have lithium, beryllium, and boron. Okay. So I have, let's make a note down here. Lithium, beryllium, boron. And I'm looking for radius, electronegativity, electron shells, and electrons in first shell. Okay, so I kind of just made a little graph about all of those things. Okay, so let's go start finding out this information. Okay, so I can do electron shells and electrons in the first shell by looking at the periodic table. So let's do that. Electrons in the first shell. 2, 2, 2. So electrons in the first shell. Okay. Number of electron shells. 1, 2 electron shells. 1, 2 electron shells. 1, 2 electron shells. Okay, so that's the same. So we have atomic radius and electronegativity. So for that, I'm going to need to go to table S. Okay. And I'm going to look, I don't have to know specific numbers. I want to see what is happening. So for electronegativity, from lithium to beryllium to boron, electronegativity is going up. And let's see what's happening to atomic radius. 130, 99, 84 is going down. So let's go back to my question. It says there's an increase in, so which one was increasing? Electronegativity. Okay. Which element is classified as a metalloid? All right, so let's see. On the periodic table, we have metalloids touching the staircase with the exception of aluminum. That's a metal. So metalloid, 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 metalloid. So which one of these options? It is boron. Right there. Strontium and barium have similar chemical properties because atoms of these elements have the same number of. Now, I don't even need to look it up, but I'll just show you. So strontium and barium, which are right here, they're in the same group, in group 2. Why do they have similar chemical properties? Because they have the same number of valence electrons. Which term represents the fixed proportion of elements in a compound? So like, for example, H2O means water has 2 hydrogens and 1 oxygen. And H2O2, hydrogen peroxide, has 2 hydrogens and 2 oxygens. It's the chemical formula. Which 2 terms represent types of chemical formulas? So we can have molecular, we can have empirical, and we can have structural. So what do we got? Mechanical? What? That is not even a type of formula. So there we go, molecular and structural. And then this question, which it looks like we already answered, but these were our notes from above. Which element has metallic bonds at room temperature? So if it has metallic bonds, it is a metal, period, end of story. So on the periodic table, what are we looking for? Non-metal. We have non-metals on this side. These are noble gases. Metalloids touching the staircase, except for aluminum, right? That's a metal. And then everything over here and everything down here, those are all metals. So that is going to be, so bromine, right here, non-metal. Cesium, right here. Oh, metal. Let's just see krypton, right here, noble gas. And sulfur right here, non-metal. Okay. What is the number of electrons shared between the atoms in a molecule of nitrogen? N2. So N2. So N has 5 valence electrons, so it's Lewis dot structure. Looks like this. So when we bond 2 nitrogens together, these paired electrons don't bond, so they're going to stay on this side. So now they're going to bond. But we can't leave unpaired electrons, so what will happen is it looks like this. That's nitrogen. Okay, that's definitely one you need to remember. And so this is, what is the number of electrons? Well, each line represents 2 electrons, so 2, 4, 6 electrons, or it would be 3 pairs if it asked about pairs. So given this equation, what is occurring during this reaction? Well, first what you should look at is what is happening. So I'm taking an H and making an H2. So am I breaking a bond or forming a bond? So you should realize you're forming a bond and get rid of 2 answers because they are breaking. So that's definitely wrong. All right, and when you form a bond, so here's my recommendation. When you break something, it takes energy. So breaking pairs with absorbing. So forming forms with releasing. An atom of which element has the strongest attraction for electrons in a chemical bond? That is the definition for electronegativity. Okay, that is a definition for electronegativity. So I just have to look up which one has the greatest electronegativity. So I'm going to go here to the reference table. Chlorine, 3.2. Carbon, 2.6. Phosphorus, 2.2. And sulfur, 2.6. So which one has the greatest? Right there. Oops. Chlorine. I'm going to circle that badly. At STP, a 50-gram sample of H2O liquid and a 100-gram sample of H2O liquid have, well, I still have H2O liquid. So if I have H2O liquid, they have the same chemical properties. They don't have the same volume. They're not at different temperatures because it's at STP. That means it's at standard temperature. And they don't have different empirical formulas because they have the same chemical formula. Which statement describes a mixture of sand and water at room temperature? So when you mix sand and water, do they mix together? No, they do not. So it is heterogeneous. So they're not evenly mixed. And its components are in the same phase or different phase. Well, what does phase mean? Phase means states of matter. So solid, liquid, and gas. Well, when we mix sand and water, does the sand dissolve? No, it does not. So the sand stays a solid and the water is a liquid. So they are in different phases. Okay. Distillation is a process used to separate a mixture of liquids based on different boiling points. Okay, that's just kind of remember that one. According to the kinetic molecular theory, which statement describes the particles in a sample of an ideal gas? So they're rapidly moving straight line paths. They have no molecular forces, intermolecular forces. They have negligible or tiny volume compared to like where they are in the container. So are they moving in circular paths? That's not true. Do they have attractive forces? No, that's not true. So I have 2 crossed out. So it's either the particles collide, decreasing the total energy, or the particles are considered to have negligible volume. It's this. This is describing an inelastic collision, and in an ideal gas, the collisions are elastic, meaning the total energy gets transferred. Which sample of matter has the greatest distance between molecules at STP? So this seems like it's a hard question, but it's literally not. Where do we have the greatest distance between particles? If they're at the same temperature, it's just going to depend on state of matter. So it's just the gas. For a chemical system at equilibrium, the concentration of both the reactants and the products must be, so concentrations is constant. Rates are equal, so constant. In terms of the disorder and energy, systems in nature have a tendency to undergo changes toward, remember, they take the easy way out, so that is lower energy. So we're going to get rid of this because that's higher energy. Disorder, which is entropy, right? Well, it takes a lot of energy to put things in order. Okay, that's how I have my classroom, super ordered. It takes energy. So nature doesn't like to use energy, so it's going to have greater disorder and lower energy. The only 2 elements in alkenes and alkynes. If you forgot this, this is a super easy reference table question. You just go to table Q and look. What are the only 2 elements? Carbon and hydrogen. Which functional group contains a nitrogen atom and an oxygen atom? So I know this, but don't guess. Go to table R. At the bottom is where we have nitrogen. So what functional group, right? What compounds, right? So we have nitrogen and an oxygen right here in an amide, right? Amide, this one. So be careful because that one does not have an oxygen. All right, so let's continue on with the multiple choice. Which sample of magnesium reacts completely with oxygen? When a sample of magnesium reacts completely with oxygen, the magnesium loses 5 moles of electrons. How many moles of electrons are gained by the oxygen? Well, in a reaction, we have to have conservation of charge, conservation of atoms. So in this case, we have to have conservation of electrons. So if we lost 5 moles of electrons, we have to gain 5 moles of electrons. Hopefully that makes sense. Which statement best describes the reactions in an electrochemical cell? All right, so remember this. An, ox, red, cat. Oxidation at the anode, reduction at the cathode. There we go. A 0.050 molar aqueous solution of which compound is the best conductor? So conductors are electrolytes. So they're acids, bases, and salts. Okay, so this is not an acid, base, or salt. This is not an acid, base, or salt. Salt, salt. How can I tell it's a salt? It's ionic. It has a metal in it. Now I have to decide between these two. Well, what I need to decide is how many ions it breaks into, because more ions is better conductor. So this is going to break into 1 Mg, 2 plus, and 1 SO4, 2 negative. This is going to break into 2 K pluses and 1 SO4 negative 2. So which one has more ions? This one. More ions, better conductor. What is the color of bromcresol green indicator in a solution with a pH value of 2.0? So go to the reference table, table M, find bromcresol green, pH of 2. So below 3.8, which 2 is below it, is going to be yellow. Okay. Which formula can represent hydrogen ions in an aqueous solution? Remember, hydrogen ions, which is H+, rarely stay by themselves when they're mixed with water. They kind of attach themselves to water and become hydronium ions. In which reaction is an atom of one element converted into an atom of another element? That's basically the definition of a transmutation, a type of nuclear reaction. In which type of nuclear reaction do nuclei combine to form a nucleus with greater mass? So the joining is fusion. Fission is splitting it apart by hitting it with a nucleus. Okay. All right, now we are going to move on to part B-1. B-1 is the next set of multiple choice questions, and these questions might be a little bit more involved. Okay, so directions up here. This says the bright line spectra produced by 4 elements are represented in diagram. Given the bright line spectrum of a mixture formed from 2 of these elements, which elements are present in the mixture? Now this question is sort of annoying because you can see it doesn't line up. So 400 is here, but like it's shifted over, so I have to do a little bit extra. So I'm going to look for easy things. So do you see element D has 2 bands between 600 and 550? So between 600 and 550, do I see 2 bands like this? No, that means I can eliminate D. And you see X right here, it has 2 bands between 750 and 700. Do I have 2 bands between 750 and 700? No, that means I'm left with A and Z, which I can see 1, 2. So, I mean, you could match them up. So this is at 670, 670, 610, 610, 500, and 460 right there. And then Z, we have 705. We have 665 right there. We have 500, 60, 70, 585 right there. And then we have about 445 and 470. So there we go. It is definitely A and Z. So I kind of answered it at first without even looking for what was there by looking what wasn't there. But that just literally confirmed it. Okay. Let's just focus this a little bit. It got a little fuzzy. Okay. Which electron configuration represents the electrons in an atom of sulfur in the excited state? So first let's get sulfur in the ground state. How do I do that? I just look at the periodic table. So sulfur in the ground state is 286. So in ground state it is 286. If I total those up, that's 16 electrons. So 286 is wrong because that's ground state. I'm looking for excited state. And what I can usually do now is eliminate based on total electrons. I need 16 electrons. So 2 plus 8 is 10 plus 7 is 17. Wrong. 2 plus 7 is 9 plus 8 is 17. Wrong. 2 plus 7 is 9 plus 6 plus 7 is 16. So what happened is one of these electrons, boop, bumped to a higher energy level. So it's excited state. One electron is higher than it belongs. Which notations represent atoms that have the same number of protons but a different number of neutrons? So here we're looking for isotopes. So it has to be the same element. So you see these are different elements, so that's wrong. These are different elements, so that's wrong. So now I'm left with these two. If they have the same number of protons, same element, different number of neutrons means they have a different mass number. So it would have to be this one. These ones have the same mass number, so it's literally just the same thing. Okay. What is the chemical name of this compound? This is actually pretty easy. Go to table E. What is NH4? Ammonium. Okay, so it's this. It doesn't start with this. It starts with ammonium. Now we need SCN, thiocyanate. There we go. Which equation represents a conservation of atoms? So that means I need the same number and kind of atoms on both sides. 2Fe, 2Fe. 2 times 2 is 4O, 3O. Nope. 2Fe, 2Fe. 3 times 2 is 6O, 3O. Nope. 4Fe, 2 times 2 is 4Fe. Yep. 2 times 2 is 4O. 2 times 3 is 6O. Nope. Well, hopefully this one is right. 4Fe, 2 times 2 is 4Fe. 3 times 2 is 6O. 2 times 3 is 6O. All right. Which compound has covalent bonds? So I need 2 non-metals. Okay, if you don't remember, on the periodic table, non-metals over here, but also hydrogen. So when I look it up, metal, metal, metal. There we go. Which particle diagram represents a sample of oxygen gas at STP? Here's what you have to remember about oxygen gas at STP. It is diatomic. Right? And it's a gas. So first of all, this doesn't even look like a gas. This also doesn't look like a gas. That looks more like a liquid. This looks more like a solid. So these two are gases, but you have to remember oxygen is diatomic. Remember, bring off the diatomic elements. Oxygen is one of them, so it has to look like this. At which temperature and pressure will a sample of neon gas behave most like an ideal gas? It behaves most like an ideal gas when it has tons of space, so the particles are far apart. That's low pressure. So let's get rid of the high pressure choices. Okay, it behaves most like an ideal gas when the particles are moving rapidly. They move rapidly at high temperatures. So pick the high temperature, low pressure. What is the molarity of 2 liters of an aqueous solution that contains 0.50 moles of potassium iodide? So this is a calculation. So for molarity, we need moles divided by liters. So 0.50 divided by 2. So what I can tell you right now is you should realize the answer is not going to be this. It's also not going to be this. So it's going to be one of those, right? So, which basically, if you aren't sure, just check it on the calculator, right? 0.50 divided by 2, 0.25. If you weren't sure, check it on the calculator. Here are the volume of 4 samples of gaseous compounds at 298 Kelvin and 101.3 kPa. Which 2 samples contain the same number of molecules? So they're at the same temperature and they're at the same pressure. So when do they contain the same number of molecules? When they have the same volume. So these two have the same volume. So that is 1 and 3. Hydrochloric acid reacts faster with powdered zinc than with an equal mass of zinc strips because the greater surface area of the powdered zinc does what? It increases the frequency of collisions. They hit more often in when there's greater surface area. All right, we're almost done with the multiple choice. So given this an equation representing a system at equilibrium in a sealed rigid container, increasing the temperature of the system causes what? So increase the temperature means increase energy, which shifts the equilibrium this way. When the equilibrium shifts this way, this starts to go down, this starts to go down, and this starts to go up. So that is the correct answer. All right, based on table I, so again, if you don't turn to table I, well, that is really problematic, right? Because you absolutely need to do that. So based on table I, which equation represents a reaction with the greatest difference between the potential energy of the products and the potential energy of the reactants? So this question, the difference between the potential energy of the products and the potential energy of the reactants, is delta H. So it's saying which one has the biggest delta H. So that's literally not a hard question. I just have to look at them, right? So first I have to find this one, which is right here, and that is negative 3351. Then I have to find this one. This one I have to be careful because there's a couple H2Os, and I need the one where it's H2O liquid. So where is it? Here we go. Negative 571.6. This one, that is propane, right? Propane. This one, negative 2219.2. And this one, that's sugar. That's the photosynthesis equation, right? So here we go, negative 2804. So which one has the greatest difference? That is going to be this one, right? That had the biggest number. So I was just looking at the numbers. Which phase change represents an increase in entropy? Entropy is disorder. So when we go like this, from solid to liquid to gas, gas has the most disorder. Nope, I'm increasing order. I'm increasing order. Oh, it looks like this one, right? Yep, there we go. Given the formula for a compound, what is the name of this compound? So, first of all, let's circle what is not a carbon or a hydrogen. So right here. Let's find this functional group in table R. It's this, right? So it should say something YL and then something NO8. There we go. Right there, right? Okay. Given this equation representing a reaction, during this reaction, each element changes in Well, the elements didn't change in atomic number because that would mean they turned into something else, but it stayed calcium and oxygen. What about oxidation number? Oxidation number 0, oxidation number 0, oxidation +2, oxidation -2. Yes, they absolutely do. Do they change the number of protons? No, the elements stayed the same. The only thing that changed was the oxidation number. Which equation represents a spontaneous reaction? Okay, this is a table J question. So I got to go to table J. And the rule for table J is that a single metal will kick out an ion if it's higher. Okay, so if it's spontaneous, the single metal has to be higher than the ion. So is Ca higher than Ba? No, it can't kick it out. Is CO higher than Zn? No, it can't kick it out. Is Fe higher than Mg? No, it can't kick it out. Is Mn higher than Ni? Yes. Look, Ni is all the way down here. Mn is higher. Now, what if you didn't remember? Well, you could do process of elimination. Like one of these things is not like the others. This one would have the metal lower, metal lower, metal lower, metal higher. Or the ion would have been higher, 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 lower. So you could have done it by process of elimination if you forgot which way it went, and then do the Sesame Street. One of these things is not like the others. Do that. Which equation represents neutralization? Neutralization is acid plus base yields water plus salt. So I'm going to cross out this one and this one because I don't have water. Okay? So I need an acid and a base. If you don't remember which ones are acids and bases, then have a quick glance at table K and table L. Look for which ones are acids and bases, but that is going to be right here. Which radioisotope requires long-term storage as a method of disposal to protect living things from radiation exposure over time? So, like, you don't have to remember that. Look at table N. Which one of these is going to be on table N? And what you will see is, look at this, francium 220. All the, and then we have lead 53, so 8.51 minutes. Francium 220, 27.4 seconds. Then we have, right here, phosphorus 32, 14.28 days. And then we have plutonium 239 is 2.410 times 10 to the 4th years. So which one requires long-term storage? Well, this decays so quickly in seconds, right? So it's 100, then it's 50 in 27.4 seconds. This one only takes minutes. This one takes days. So this one is going to require long-term storage solution because the half-life is so long. All right, we have one more multiple choice question. Ready? Here we go. Given this equation representing a reaction, which statement explains the energy term in this reaction? So you can see when I add this up, well, I didn't even have to add it. They added it for me. This is the total mass on this side, and this is the total mass on this side. Which statement explains the energy term? Mass gets lost and converted into energy. So mass is lost, and because the mass is converted into energy. So that's it. That is the multiple choice questions on the August 19 exam, and hopefully that helped.